Okay, so we are going to be talking about quadratics, but this time we're going to be graphing quadratics using a focus and a directrix. So you've got this picture right here. It looks pretty similar to when we were talking about axis of symmetry and all of the other special points and special attributes that we have for a parabola. But this time we have a couple of things that are different. Let's look at what's the same, first of all. We still have our vertex, and we always label our vertex H and K. That's our very minimum or maximum point. We still have our axis of symmetry that goes through the center of our parabola. It cuts it in half so that both sides are symmetric. And it's always going to be the equation x equals the h value, the x value of our vertex when our parabola opens up and down. But this is something new. We have something called a focus and we have something called a directrix. A focus is a point and the directrix is a line. And the thing about a parabola is if you take a vertex and you measure your distance up or down to your focus, and you measure your distance up or down to your directrix, those two distances are always going to be the exact same value. Now, if I draw a really nice parabola, if I'm capable of doing that with, whatever this is, technology or by hand, it doesn't matter where I am on my parabola. So let's, for example, take this point right here. If I draw a line directly to my focus, and from the exact same point, I draw a line to my directrix, those two lines should be the same length. All right, so let's look at some vocabulary. All of this is typed out for you at the bottom of your note sheet. If you don't have it, you can download it online or you can come and get it from me in the classroom. Either way is fine. But your p value is just the distance between the focus and the vertex, as well as the distance between the vertex and the directrix. We are going to use that information to create an equation after today. So at this point, this is what I want you to know. Your p value, which is always going to be positive because p is a distance, is equal to the absolute value of 1 over 4a. This is what I want you to keep in mind. If I want you later on to write an equation, that means we've got to figure out what our a value is. Your a value, or the absolute value of your a value, is going to be equal to 1 over 4p. That's how the two are related. Now we've got to use the absolute value of a because remember, p is always a distance. So this fraction right here is always going to be positive no matter what. That's why we put the absolute value around our a value, because a could in fact be negative if our parabola opens down. All right, so let's do some practice. We're going to find, for each example, we're going to find the missing pieces. So if I look at this first problem right here in the upper left corner of our note sheet, it says our p-value is 3, our vertex is located at 4, -5, and our parabola opens up. So if our vertex is located at +4, -5, that's this point right here. We went to the right 4 and down 5. Our p-value is 3. That means the distance from our vertex to our focus is 3 steps. So all I need to do is start at my vertex and I'm going to count up 3 steps because our parabola opens up. If our parabola opens up, our focus is going to open up. We're focusing upward, all right? So our focus is going to be up. Now, we know that this distance right here is 3. That means if I start at my vertex and I go down 3 steps, I should be able to find my directrix. Now, the directrix is not a point. It is a line. So I have got to draw this horizontal line that goes through my y-axis at -8. That means the equation of that directrix is y equals -8. Do not forget, if you have a horizontal line, it's always y equals. And if you wanted to draw a rough sketch, you could. Your vertex is, again, at 4, -5. And just knowing that our parabola opens up, it's going to look something like that. okay? Don't forget, the distance from the vertex to the focus was 3, so the distance from the vertex to the directrix is also 3. All right, let's do another example. This time we're given the vertex and the directrix. So if I look at my problem, I know my vertex is left 5, up 4, right there. And we are also told that our directrix is at y equals positive 8. So I'm going to go up here to positive 8 on my y-axis, and I know that my directrix has got to cross through that y value. No matter where we are on this blue line, the y value is equal to positive 8. Now, they didn't tell us which direction this parabola opens, but remember, your vertex is always in the center between your focus and directrix. Just like our first example, the vertex was in the middle. So the same is going to be true here. Our vertex is at negative 5, 4, and it's going to be in between our focus and our directrix. So how many steps does it take for us to get from the directrix to the vertex? You can just count on your graph. 1, 2, 3, 4. That's 4 steps. So we know our p-value is equal to 4. That means all I've got to do to figure out where the directrix is go start at our vertex and go 4 steps in the opposite direction. 1, 2, 3, 4. And we end up at negative 5, 0. That's where our focus is. So is this parabola going to open up or down? If our directrix is above and our focus is down, so we're going to open down. The focus of our parabola opens down. Our parabola and our directrix, that purple graph and the blue line, will never, ever, 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 ever intersect. Not ever. The focus is always in the bowl-shaped part of your parabola. All right, let's do another one. If I give you the vertex, which is at 2, 2, so I'm going to go to the right 2 and up 2. And then we give you a focus, which is at 2, 1.5. So I'm going to go to the right 2, and I'm going to go up 1.5 steps this time. Ooh, that's tiny. How many steps apart are the vertex and the focus? And if you want to label this with a V and you want to label this with an F so that you remember which is which, I always feel like that's a good idea, especially if you're doing something in pencil and you can't color code. So I'm looking at this and I see, okay, I know my focus is below the vertex. It's down. So I automatically know my parabola is going to open down no matter what. Pretend like that looks good. How far apart are the vertex and the focus from each other? So I can tell right here, our p-value is just 0.5. So all I've got to do is say that my p-value is equal to 0.5. Now, if that's my p-value and they're half a step apart, all I've got to do is count up in the opposite direction a half of a step, and I can figure out where the directrix is. So I'm going to start at my vertex. I'm going to go up half a step. And that right there is where my directrix is. What y value did we just cut through on our y-axis? That was 2.5. So I know my directrix is located at y equals 2.5. And I know that we didn't write it down on our last problem, but which direction did our parabola open? We opened down. And on this problem right here, we also opened down. All right, let's look at our last example. This time we're given our focus, which is located at positive 3, negative 4. So we're going to go to the right 3 and down 4. That's our focus. We'll label it with an F. And our directrix is located at y equals 2. Y equals positive 2. So I'm going to cut through my y-axis at positive 2. No matter where I am on that line, the y value is equal to 2. So this time we don't have the vertex. We have to figure out where that's supposed to be. And our vertex is always in the middle. So how many steps does it take to get from my directrix to my focus? And if I count, I see 1, 2, 3, 4, 5, 6 steps. Okay, that's 6 steps. But that's the entire distance. What's the halfway point? In this case, 6 divided by 2 gives us 3. So our p-value is going to equal 3. Start from your focus and just count up 1, 2, 3 steps. And that's where our vertex is located. Our vertex is located at 3, comma, -1. If you want to label it with a V on your graph, that's great also. Now, one more question. Which direction is this parabola going to open? Remember, our focus is down, so we're going to open down. Our focus is always in the bowl-shaped part of our parabola. Also, our parabola will never cross our directrix. So that's the direction of opening. And that is your little tutorial on that.